Hello everyone, this is A.THASNI from Department of Computer Science and Designing from SNS College of Technology. And today we are going to see about the topic from the unit called as implementation technique. And in the from that in the topic called as column oriented data storage. The reference to the previous topic, there we have seen the data dictionary storage, and here we are going to see about the how we are organizing the data in a column way. So the to today's power, like we can explore the architecture with the high performance analytical database. So why storage architecture matters in database? We have two type of organizing the database, which is in a row oriented and column oriented. In the row oriented is nothing but which is in a traditional way where a group of all data of a record together on disk, making it ideal for transactional workload where you need access to complete the records quickly. But whereas in column oriented, we are grouping the data by columns, dramatically optimizing the analytical queries by reading only the data you actually need for your analysis. So the fundamental architecture difference shapes everything like performance, characteristics, compression ratio, query pattern, and scalability limits. Here we can compare the row oriented and column oriented. Like in a row oriented, we store the entire row contiguously on disk, excelling at a single record operation like inserting a new customer or updating an order status. Whereas in a column oriented, we store each column contiguously, excelling at scanning and aggregating large data set for analytics and business intelligence queries. So the performance of each columnar storage, which is in a superior compression, vectorized execution, and reduced input output. Like in superior compression, like similar data types are stored together dramatically, which reduce the entropy, which enabling advanced compression algorithm like run length encoding and dictionary compression. Whereas in vectorized execution, which process data in batches of thousands of values at once. We are maximizing the CPU efficiency through SIMD instruction and cache-friendly memory access pattern. In reduced I/O, it read only relevant column from disk, minimizing disk access and memory usage. These techniques are enabled to lightning fast aggregation filtering and analysis. Implementation techniques and modern columnar database, which is in a positional encoding, columnar file format, in-memory column stores, massively parallel processing. Whereas in positional encoding, which uses the virtual IDs to link column values by their position in the file, which eliminating redundant keys and reducing storage overhead while maintaining relational integrity. Whereas in columnar file format, which leverages format like Apache Parquet and ORC for efficient storage. And in memory column stores, like a system like SAP HANA combine a columnar layout with RAM speed access for ultra low latency queries. Whereas in massively parallel processing, which distributes column data across multiple servers, enabling scalability and parallel query execution. So we are going to see about the case study which called as SAP HANA's in-memory columnar architecture. So in the memory first design, we are going to store the data in high-speed RAM organized by column, eliminating the traditional disk I/O bottlenecks and enabling real-time analytics at unprecedented scale. Where a hybrid HATAP platform like HTAP, which supports the transactional and analytical processing on a single unified platform, which removing the need for separate OLTP and OLAP system. And the sub-second performance is nothing but which achieves the sub-second query response time on a multi-terabyte dataset through advanced compression. And another one is the intelligent optimization, which uses advanced compression algorithm and a multi-version of data footprint. Here we can see some real-world example of columnar database, which is in a DuckDeep database, Cloud Native Giants, and TinyBit. So Duck database is nothing but which is a lightweight embeddable columnar engine optimized for analytical queries. And Cloud Native Giants is Snowflake, BigQuery, and ClickHouse deliver cloud native form. And TinyBirds is real-time analytics performing platform which leveraging a columnar storage architecture. So when to choose a columnar storage, which is a read-heavy analytical workload involving large data set, queries aggregating or filtering a subset of columns over millions of rows, and less suited for which is a write-heavy transactional workload, frequent single row updates or deletes. Challenges and limitations is nothing but we are going to see about the row reconstruction complexity, write performance overhead, transactional limitations, and columnar storage powers with the modern analytics, which comes under the revolutionary performance and advanced technique and strategic choice. So that's all about the column oriented storage. Thank you.